Hanif Kara has over 40 years experience in the industry. He's a co-founder and design director of the Interdisciplinary Engineer Practice, AKT, which today works throughout Saudi Arabia and across 50 countries globally. Hanif also is a professor in a practice at Harvard University Graduate School of Design, having taught with further architecture school throughout Europe. In 2022, Hanif received the Council for Building an Urban Habitat Fazl Khan Lifetime Achievement Model and was made an Officer of the Order of British Empire, OBE, for his service in architecture and engineering and education. He also the first structural engineer to be awarded the prestigious Swanee Model in 2023, and also the London Design Model at the same year. He's widely published in the field of design, and Hanif's work spans innovative structures, material efficiency, sustainability, and interdisciplinary collaboration. Under his leadership, AKT has won hundreds of design awards, including multiple Repastering Prize. I believe it's around 250, right? Awards. Wow. So it's an honor, and I'm so delighted to introduce you, Hanif. So please join me to welcome Hanif to the stage.
Bismillah. First of all, I have to say that structural engineering can be quite boring. So whenever I'm invited to speak, I have to find mechanisms to keep people awake. And it wasn't difficult to imagine that the title, a mirage of what we do, could be quite interesting to think about. The mirage being that often the work of engineers is hidden and we don't know what's going on, especially when we look back at the history of our construction, especially when we look in the regions like this, where things have existed from medieval times and pre-Islam to some extent. And you see that and connect that to the future. So while I'm mostly a technologist, I thought it was vital that I try and connect what I can for the next generation and leave some of the kernels of what could be good for us. To do that, I broke it into 4 chunks. The first chunk is really about provocation. And please, if I offend anyone, it's not meant to offend you, or you're too sensitive and you shouldn't be. That will set a position, a universal position. The second chunk is eastfulness, which is really gazing at the east from the west. And then the next chunk is 40 years of being in the west and now dying to make life westlessness somehow. And the last thing I want to talk about is earthbound, what binds us all together. So starting with the first title, I start with a very simple story which is very well known, survivorship bias. After the Second World War, we engineers looked at, or my ancestors in engineering, looked at how some planes were coming back and surviving. And they plotted this map, all the pink zones are where planes came back with bullets. All the green zones were where they didn't come back. And it wasn't until nearly 70 years later that somebody figured out that the ones that are in the green zone were a blind spot. And the reason they didn't come back is because they were destroyed. So basically engineers were looking at the wrong thing and reinforcing the pink zones unnecessarily. So at the end of my lecture, I will have missed a lot. I will not have covered all the blind sides, but it's vital to get that apology out of the way from the beginning. I want to start with the provocation about one planet and a deglobalizing world. And I usually talk about it on the basis of a lot of work that's been done in LSE, but in many other countries in the world. But this particular map tells us something very simple, that the East or the global South is now in a process of coming into its own era. The epoch has changed. So on the one hand, urbanization is going up at a rate that the countries at the top are doing things that are new. Countries at the bottom right are the ones that cannot build anymore. They already have enough buildings to live in. But what's interesting about this, if you see it straight away, Saudi Arabia is missing in this research. The whole continent of Africa is missing. And I see this quite often, where the gaze from the East and the West sometimes forgets to pinpoint other things. If I go back, if I swap that around, and we look at the other way around, and we look at the way in which retrofit opportunities are now happening, evidence is clear that the zones that were at the bottom again are moving right into the top right. So most of these countries on the right are building cities from existing cities, according to them. But they don't, again, take into account places like Africa or the Middle East, regions like the Middle East. So this phenomenon is very interesting, and I think the next 100 years, this is what we're going to face. The reason why I put those slides up first is in the 1960s, the Western people told us that, particularly this book and the movement that described the population bomb at the time, told us that the poor people should be stopped from having any more kids, and there will be a population bomb that will kill the Western way of living. That's been proven wrong, as you can see from the last two slides. What you see, in fact, and if you took a survey of what is inequity about the things I'm talking about, I refer to this particular data, which comes from looking at the UN countries, just the Commonwealth countries. And what you see in terms of the population versus the amount of carbon they've spent in the last 100 years, but also continue to spend, you realize how much damage that way of thinking, build, and continue to build as a capitalist idea has affected us. And what's really interesting about this is that 250 million people, which is the zone that you can see at the bottom, the urban growth of people. So say Canada and the United Kingdom are two that I've identified. The populations are small, but the amount of carbon they've created is ridiculously high. When you look at the rest of the world, 2.27 billion people compared to 250 million produce 9 times less carbon footprint. So you can see that there is something skewed about equity in the way progress and civilization has been at least chased by engineers and architects. So this is quite an important decision for me, because in the last 5 years, after building a lot, I've been rethinking both in education and in practice what we should do. So one of the reasons I thought about that very carefully was because also in 2019, we learned as scientists for the first time that the amount of biomaterial that God gave us, so let's just say nature gave us, the global biomass, which is about 1,120 gigatons, was exceeded in 2019. The blue tower is showing you how much we had made as people, the human beings, had exceeded it by a certain amount. So 2019 was a trigger point for a lot of scientists and technologists as to we have a problem, or there is a new opportunity coming. If we start to look at the data, what should we do with this rather than be depressed about it? And why that's vital is that was in 2020, and what we're seeing now is that these trends are getting higher and higher to the point where by 2040, you can see how we will peak. So we're producing something like 30 gigatons as a global society of carbon footprint. And if we continue at this rate, the world has a massive problem that's totally irreversible. Some aspects already are. So the provocation of that, when I reverse engineer it to rethink why that has happened and go back all the way to 4,000 years ago, architecture, engineering, construction used to be on the left. And then along modernization, post-industrial revolution, the model changed. So we went from that idea where you didn't need engineers or architects, clients could build, design, and construct, to the idea to the right, slowly moving into many, many disciplines, and having to then add more and more technologies, thinking that all of this modernization was doing us good. I'm not saying we shouldn't be modern. I'm saying that some of the causes of the last things I've been talking about were to do with technology, the bad side of technology. And some of them were to do with people's demands and abundant hunger. That would not matter. It would not matter too much until you get down to where 2020 is. If you were born after a certain year, you're not waiting for climate change. It's here already for you, in the sense that anybody who was born after 2020 is already being affected by the social impact and also the rubbish that we created as a society before. Obviously, people of my age can care less because we will be gone before most of the problems start. This is the thing that bothers me enormously and keeps me awake. I have 2 young children, not young anymore, and I'm always thinking about what could happen to them and what are the opportunities that they will have if they don't start to address some of this themselves. And in my education, I'm always talking about that. And when I look at UN reports, I'm always trying to observe what's going on. Most of this is already on the backs of many communities. We are still waiting. Many of the developed world are waiting for this to happen, but much of the world, the climate change is on their back. They are carrying the problems, and there's regular reports of these kind of things happening. So one of the other reasons that I believe it has happened, and I've said to you this will be a provocation, is the way in which we changed how we imagine things. In Italy, 30 or 40 years ago, the Olympic Stadium looked like this. Not only beautiful, but it's about 60 meters wide. And then not long ago, the Olympics happened in China. Look at the scale. It went from 60 to 330 meters. This is human desire to show off to some extent, but also technological prowess. Because as structural engineers, we all woke up one morning, saw this, and got really excited. Because to us, this was beauty of engineering. Look at the scale we can do, and look how wonderful it is. But when I start to look back at it again, one of the phenomenon that it created was that it could be even a shoe in the same shape. So we started to not differentiate between idea and reality. Everything, scale was no longer an issue because of the digital arrival. And shoes were made to actually that scale, as well as stadiums to a 330-meter scale in this kind of conceptual idea of architecture. All that wouldn't matter until doing the calculation. I calculated 5 years ago that the Beijing Stadium, if you made a belt out of it, would wrap around the globe 4 times in steel. And that year, it took nearly 40% of the world's steel. Something is wrong. And we, as engineers, need to rethink it. Human society doesn't know some of this because we don't tell them. So concealed in many ways. You're just the user. So I arrive at the end of kind of my provocation, and it's always better to use somebody else's words than yours in these situations, because nobody believes you because you're just standing there in front of them. But a very, very well-known philosopher, James Baldwin, African-American, who I read a lot, he once said that not everything is faced can be changed. But nothing can be changed until we face it. So this is where I was in 2019, and everything you're now going to see is the work that I've done since then. It also comes from an African proverb, very simple proverb, that ants can move elephants. So if all of us can put together a lot of things, the disaster that's coming from climate, if we all activate in different degrees, all generations, we can move the elephant to a point where I think we will be safer. So I'm grateful to be speaking in a place of knowledge. That's one of the most important things, a library. A symbol also of cultural renaissance for you, but also for many of us who are observers of projects like this. But I also find myself all the time no longer deeply reading, which is an issue, especially when you come to buildings like this. I simply graze all the time. I'm grazing, clicking, and doom scrolling. So if I'm doing that, I worry about what everybody is doing, all the kids. And it's in a world that's ruled by incendiary phrases quite often, a world where truth is loitering, just backstage, waiting to make an entrance one day soon. So my following chapters are all about trying to tell you as much truth as I can, because I'm reached a point in my life where I don't need to prove anything. But being very idiomatic about it, this is what I encounter still amongst my clients, amongst architects and engineers. I encounter this all the time. I see dolphins, and in theory, dolphins are very intelligent, and they apparently they speak a language, but you have to be able to speak dolphin to understand what they're doing. I see a lot of people like that. I see a lot of people who are fish, but they're also trying to fly. So they can't swim well, but they can't fly well. And then between those two is the most dangerous in some ways, which is a genetically modified version of those two, who I call the technologists. And I feel I'm one of those in some ways, because it's mutated from those two models to here. And then a lot is to blame with the octopus, because the octopus in my eyes is many hands, none of them stronger than the other. I feel that this is the one of the provocations that can change things. And I haven't just talked about it, I've written well about it, and I have returned from some of the other models to really theorizing what does interdisciplinary actually mean for an engineer. And really that's about seeing what the other people are saying and looking at their view without losing your own way of thinking. So interdisciplinarity is the only way, in my opinion, that the transdisciplinary problem of the climate and social issues can be resolved. And it's something that is difficult to teach. You can't simplify it very easily, but I'm seeing the behavior of that as a necessity to change some of the things I've already been saying. And in education, you do that very quickly. So I promised Prince Faisal I would show my first ever building, which was done in 2000. It was finished in 2000. It was my first ever project. It won the UK Building of the Year. And it was a library, so it was the first Sterling Prize. And I show it because I remember very, very much that one of the reasons we managed to build it in this crazy way, it was in Southwark, in an area that was socially deprived, in an area that had 18 nationalities, and the most unhealthiest place in Western Europe. So the competition really was about culture, technology, but more than anything, the research, which told us that at the age of 9, if you go to the library, often, and there's a lot of evidence of it, you will be a different human being if you live your life after that. So one of the things that we tried to do with this building really was to draw in kids that were 9 early from many nationalities in Southwark, which it succeeded to do. And Tony Blair made it his Building of the Year, and the rest is history that I won't go into. But you can see that some of the moves we made in here were neither architectural nor engineering. It was about creating a public sphere. Following that, obviously, and I need to just outline some of this, I built a lot of buildings in London, so I've got a lot of practice. But all of the time I've invested right from the beginning, and I believe research is vital. I invest a lot of our work, free of charge most of the time, in pushing things, different things, artists, architecture, designers, materials, because if you don't reinvest in yourself with this stuff, you cannot stand here and do these kind of talks, but you also can't improve the world. I also found myself in this arena, all those technologies and all that thinking was easy, because when the Olympics arrived in the UK, managed to win nearly 10 competitions in that particular park, which kind of shows it's an evidence-based, let's say, show-off in a way, to tell you that some of the things I'm telling you about are evidence-based. They're not just things I'm making up. Much of the work is quite well known, and I won't go into it. And amongst that, I've also had constant companions that you have to have in life. can't just do your job. One of those is the Aga Khan Award for Architecture, which I've been part of for nearly 25 years. And I came here in 2015 when this wonderful building got shortlisted, and Wadi Hanifa won around about that. So having constant companions that are not paying you, but, that are really talking about the world, but also the people you come across when you have all this variety of things that you get involved in are vital to this. And this is part of the reason I continue to speak in public. I continue to try and challenge people to do what I want. Amongst that, I've also had a large impact, and I work as a consultant for the Historic Cities program on projects like Al-Azhar Park, but on many conservations. And then the last companion, which is in some ways an independent ecosystem from Harvard. So 15 years ago, I wrote a book about the things I'm talking about. I was talking then. And without a PhD, I was invited to a professorship, which I pitched for. 6 people were interviewed. And I have been a professor there since then. And before that, I taught a lot. So it's vital to me to have an additional ecosystem. Why? Because it's the only time that I can actually experiment. So one example is I've been studying extreme environments and extreme materials. So one of my first projects at Harvard was to work with my students in a project with Spela Vidnik, a very young architect. Together we set up a studio that was trying to save lives on top of this particular rock in Ljubljana. We had heard that people were going up there, temperature changes and people die. So we ran a studio that was really about building something up there, challenging a number of things. How do you build on a mountain? What is the technology you use? How do you save lives? So this kind of research is vital to it. And the drone company pulled out, but we still built it using a helicopter because the army by now felt sorry for us because our students had done a whole semester and designed this. We picked the winner from that. Very light construction. So I do it partly for that, but also partly for nature, because one of the things I'm accustomed to is building this in many parts of the world. This is how they build in most of their terrains, not only mountains. And I wanted to change this, so other species are also important. Amongst that research, as I said to you, I do extreme materials because I think there's a naive acceptance or biased rejection of materials. Everybody demonizes concrete and steel. Everybody thinks timber is sexy and let's build all our buildings with timber. So I continually push these things. I've been pushing stone recently, but I've also taken a whole studio to France to try and build with straw and mud to show people how difficult it is, but also what are the potentials of taking existing things and making buildings out of them. As Fahad said, Dr. Fahad said, I publish as much as I can so that we can share the knowledge. So in 2019, the other thing that the world was told was that we can deal with operational energy through using green ways of making energy. So how can we make energy that is coming from, wind, water? So we can deal with that. What we had not been able to deal with is embodied carbon. And in 2019, the regulations have become very strict, particularly in the West, and this is where there's a lot of benefit to learn from them, where the net zero direction we're heading to, all of us, also requests and insists on you knowing the carbon footprint of your material. And that has led to a whole way of rethinking. And today, where I sit, mostly is not in the new build world, nor in the let's not build ever world. I sit in the let's build clever world. That's what I'm trying to do most of the time, and I want to show you some examples of that. With that, I have theorized the whole idea of advanced reverse design, not reverse engineering, because I think walking back in the footsteps of our ancestors, we can do, and this building is an example, not just on existing buildings, if we walk back and then very fast apply some of the technologies that we now have, tools especially, data, but also scientific tools, we are way better off in terms of understanding what we should and shouldn't do. So advanced reverse design has become quite a popular thing now at Harvard. I'm teaching a big course on that. Within that, I'm trying to correct some kind of perceptions like, yes, concrete is a massive problem. But when you look at this graph, the amount that China used compared to the US or India, and I don't know where Saudi Arabia sits, we should all put some work in to actually put the region in here. We should put work in to put Africa in here so that we have a much better global picture. The reality is that when per capita, again, this changes. So per person, how much concrete people use. So rather than just throwing naive things, we have been rethinking concrete quite a lot. And we're getting close to finding many materials that are going to... Concrete is the second most built material after water. It has more than, as you saw from the graphs. There's new concrete arriving, zero carbon concrete, which you can do. I won't go through the chemistry, but we're doing a lot of experiments with universities through research where we're getting closer and closer to cleaning it up because it's not going to go away. So that's the provocations. And then technological progress, in my opinion, has long coexisted and been part of history without contradiction or conflict. So on the one hand, I accuse technology, but I do think we should slacken the tension between innovation and heritage a little bit, because these two things have caused some of the problems, certainly of the West. And I want to show you some examples of what I mean. When we worked on Mazda, now 10 years ago, it was based on a lot of research at MIT and many, I think 14 universities. And I was fortunate already to be teaching. And we pitched for a project and we won the first neighborhood with Foster and Partners. But all the research was done in Islamic cities like that. Why did they survive? This one is in Yemen. What was the logic behind them that could now be fast-tracked into modern technologies? So we took some of the lessons from this, applied that research, design research, into the neighborhood that is built and super successful. So no matter what anybody tells you about Mazda City, I can reassure you, and you should go and have a look at it. Amongst the many things we looked at, one was really looking at the idea of a scientific version of the Mushrabia. What are the patterns we can do to really tune the shading device, the privacy that you can do with these patterns? But the most important thing really was going back and measuring how successful we were. If you go to Mazda now and measure in our streets, which is on the right, against next door in the same country, the temperature difference at the same day, same time is about 4 degrees. And we only need to save 2 degrees to save the world. So my point here is if you learn from history and apply new technologies, you can get yourself into a really good position. You can also make huge mistakes. So in this case, we built a mega sun farm because we all know that in just 2 minutes, the sun delivers to Earth approximately 13 times more energy than all of humanity uses in a day. It only takes the sun that long to do that. And if that's the case, why can't we capture it? We asked ourselves that question and we put the whole thing together on site, but we never built the rest of the city. And the sand also got onto it. So technology can also make some mistakes. So this sun farm is only feeding at the moment one particular neighborhood that we built. But it wasn't lost because more recently, when we had to develop something similar in California, where Google have now learned the lessons, they were asking us, how can we create in California, roller skate to our work and, take your shirt off and still be able to produce the kind of stuff we do? So with Bjarke Ingels and Thomas Sederwijk, we won this massive competition to make what you will all have read now. These are the most efficient sun plates on the top. But not only that, but we created an inverse of Buckminster Fuller's dome. So these are structural tension systems, which, by the way, were innovated in this country by Fazlul Khan and Friotto like 50, 60 years ago, and then somewhere along the line taken away from you again in terms of innovation. So we push these boundaries from connecting a real city to the human scale and managed to build it. I just show you quickly the complexity of software that can be now very, very fast. We can produce this kind of stuff and give you results that we believe in. We can also lie to you. These colors, we can tell you, mean something, and you will believe it. So one of the things to watch is really where is the difference? How much intuition do you have as a client? But I can assure you that this one has been tested in many different ways, and it's also very successful. Along that pattern, I also asked myself the question, why do we always do square windows? And we know from this part of the world, there are many patterns in Islam. There are many theories about Islamic patterns. And we looked with Fashid Musavi at the time for a design school where we decided to change the size of the window dependent on what is being used for inside. So some are television studios, others are classrooms for the Ravensbourne Design School. And we invented a very simple pattern where you could take 6 tiles and change the window. If I just play it like that, you see, without really changing much else. It uses much less glass, but still behaves like a normal building. So we can do all of these things and produce buildings like this. And we can also go further. So in the finite sense, how do we bring desert plants back? Was a question that we asked ourselves on this particular project. So with cooking sections, a very young teaching practice in Royal College of Art, we won this competition to bring desert plants back over 3 years in Sharjah. And we put all of the tools and sensors that we've got over 3 years. And you can see that it starts like this with all our sensors. And 3 years later, we brought some of the species back in an urban condition. This is very relevant to you here in Jeddah and here and in Medina and other cities. There are some things that can still happen if we want nature to help us solve some of the problems. And bioclimatic design has become, it's an old term, but today it's a new discipline. In my office, we have about 10 people, but all over the world, people are beginning to work like this. What does it create? Well, on one scale, it was that garden in Sharjah. At another scale, it's something like this. So this project is the Sheikh Zayed National Museum in Abu Dhabi, where microclimates with Foster and partners, we all modeled a way of designing a building which is not just object. It's not just shape for the sake of shape, but it's based on the old patterns from Iran, from Middle East, about catching the wind, and then dealing with the wind and the different temperatures until it gets into the basement where the museum will be cool naturally, quite a lot of it naturally. Yes, there will be some AC, but if we bring in water and cool from the ground, we can even reduce that. So some of this bioclimatic work is applicable to architecture, to the client's benefit, and to 100-year lives. So this building is designed to live for 100 years and can perform. Just to give you an idea of scale, and maybe the metaphor that we sold at the competition stage, of course, based on the Beijing Stadium, you should never just replicate nature. You can't biomimic scale. So when a bird's feather is that big, don't make a stadium out of it. So whilst you win the competition to build it, there's a lot of evidence to show that you can change those things. And then when you're an Easterner, an Eastern person, and you have to operate in the West, how do you deal with that? This is with Zaha Hadid. I wanted to put this together with Norman Foster's Eastern project, or let's say Middle East project. This is in Michigan in the USA, where we entered a competition with Zaha. And she said, I'm not going to do a curve, because in America they cannot build curves. They're in the last century when it comes to curves, because unions don't allow them. And they don't mix concrete and steel, because unions don't allow it. So I'm coming up with a very simple idea. Can you guys make it work? I want to fold metal, because car industry from Detroit used to do it. Can I design a building like this for Broad Art? We won the competition, and this was the competition idea. Environment, structure, facade, all of it is dealt with through, she made a paper model of it at the time to say to us, why can't we do this? And so we won it. We managed to get the winning. Then the construction people came in, which happens here as well. I hear often, after you've designed it, we're going to go to a contractor. And they did. So you can see that in the end, disappointingly, they didn't build it the way we had conceived it. We didn't have any say in it. They built it in the way they build their houses, which is plywood and then a skin on top. So the beauty is still there. But going from the east to the west, sometimes you have to have a strategy and a technicality, but also an approach to how you sell your thinking. in order to get through your experiments. And I wanted to just show it to you because it's quite ridiculous what's behind the real beauty of the building. And today it's a very successful museum, very popular as well, but it was one of the few things that Zaha Hadid managed to build over there. I've also been worrying a lot and questioning myself about what is the connection between Muslim concepts, Islamic concepts, spirituality, and the spatial principles that we are forever told, particularly through other eyes. If you're a Muslim, it can be quite difficult because you can't figure out, if you just took the pursuit of knowledge, which most of us know is ilm, that can be actually interpreted in space and in gardens and so on. How do you do this? I'm still at level 1 on this. So the rest of my life, I'm going to try and work out how we can connect these things to educating both the West and the East, and is there any truth in it? The first example of it I'm able to show you because there are symbolic and all of those principles I talked about have arrived in here. This was a competition. This building opens on November the 6th. We won it as a design competition in Houston, Texas, which is very similar climate to you. So very, very important idea. The idea of oneness, which has an Arabic word as well. So start with a triangular grid, which is a very natural thing to do, and then work with that grid for the landscape and the gardens, but also the building itself. And one of the biggest conditions on this project was that Houston had flooded several times, including this site, by up to 2 meters. So when we enter the competition, which is now finished, I can say that most of the principal ideas were arrived and saved because the client as a patron and the city invited, the mayor invited this kind of innovation in the USA. You see there are very few curves in it though, but nonetheless, Houston will benefit from this. I go back to where we learned some of the things. These ideas are from old Chinese and Japanese architecture. So you look into how you make large spaces. To the right is an image from a house in Gilgit in Pakistan, where when material is only available in this scale, how do you span a big distance rather than doing what we normally do? So this idea of reciprocal systems was in my head. You go to, I'm working on a project in Bukhara, and I've been understanding very carefully how the Silk Route people worked with their ancestors to produce some of this kind of work. The right-hand side is some of the columns. So our atrium is 5, and you're all probably familiar with how important number 5 is in many of the symbolic, but also some of the verse, the 5 chapters of the Quran and many other reasons. 5 Virendil trusses that twist to create a very large dome, and the dome is flat on top. This is it almost finished. It brings light in particular. Then the triangle also goes into micro level to change the way it shades and lets light in and heating. So bioclimatics was vital. You see there the garden looking at the north, and you see these very tall columns which were inspired by, to some extent, Bukhara. And for the first time today, I saw the 100 palms in a park here, which I wasn't aware of. So symbolic ideas. This has got 49 of these super columns, as we call them, because the Ismaili religion believes in 49 imams. So all of these symbols come from that. You see the way to create a space like this in an efficient way, but also the prayer room has potential for a garden, that's a civic space for all of Houston. They can use it. And the prayer space is underneath it. And we've been able to use some very smart tools to stop it behaving like a trampoline. But again, going to the micro level, we were able to analyze wind-driven rain that will get into our tiles, but also air quality analysis, because we have 2 motorways on either side. So all this is possible, and I'm just showing it to you because it kind of triggers in me that some of these things don't get out to the world. So you can see there's a massive garden at the front and massive garden at the bottom. We did a very, very detailed analysis of where the building should be, and we were proven right in July this year when the building flooded. The whole of Houston flooded. Our building flooded like that, or our garden flooded, and 2 hours later, it was dry. Most of Houston lasted for nearly 3 weeks. So we can prove with engineering and the technologies I'm showing you already that we can deal with climate change, because this is climate changing. Floods are a common issue around that. So I just fly through the finished object, and it wasn't invented particularly in Houston. We'd done a previous project in London where we built something on the beach for the Turner Museum with David Chipperfield, and the only way we could prove it is this was already flooding by 2 meters. There isn't enough tools to do it. So we still work with physical models with universities to try and take a risk and produce that kind of work. So there's a connection. And then how do you connect this back to this region? And I wanted to just show you the fort that I did in Al-Muwajir with my team. When I say I, by the way, there's about 300 people in my office, just be aware of that. But a lot of the invention this is nearly 12 years ago. And the idea there that we had been put to task by the government was really take the old fort of Sheikh Zayed and turn it into a modern, old marriage. How can we make something that is modern with the most modern material of all? That's glass. It's now a very, very successful museum that was built, and it's been really quite amazing in terms of what we learned about mud, how we can construct with mud. But you also see some of the spaces. If you haven't ever visited, you're in the area, they don't necessarily promote this well, but if you go and see how beautiful it turned out, in that marriage, that dance between the old and the new, without either of them stepping on the toe of the other. Because when you step on the toes, you can't do the dance. One thing we learned is that we had to bring people from Asia to do the mud work, which was disappointing because there wasn't a local craft that you could make. But we took this work from the mud to bring it to high-tech level. What can we do from what we had learned? So we built this thing in Milan for one of the Milan fairs, where we basically made a tent and used drones with our students, with a really fantastic architect from Barcelona, from the IAC in Barcelona, and learned from Abu Dhabi mud, go across to Spain, Italy, and try and apply the modern version. And then, of course, world thought we were the experts in mud. So did I. I thought we were like the best people in the world. And we wanted this project with Phil and Clegg in a new academy in Bangladesh, Dhaka, as a competition again, which is built. But when we arrived on site, there was no site. It was a swamp. So one of our problems really was over 8 or 9 years to create land in a swamp which has earthquake potential. So a lot of research was done, even though the client already bought the site and already done a competition. So much of the work was really innovation. But the thing that I always admit to is how far I got it myself wrong. Because I went over there promoting the idea of dried bricks to Bangladesh. And I was told, of course, you can have them, but come and visit us first. So I went. They took me to the factories. They took me to where it's done. It's done like that on the right-hand side. And what the client said to me is, yes, you can have dried bricks, but if you don't do this, we will probably not be feeding 200 families. So is the social impact of that worth saving the bricks that you want to do? And I had to admit, no, because there's a lot of poverty in that country. And if this is a way of living, how can we reuse this? So sometimes, I told you earlier, from that airplane slide, we miss the point. We also get it wrong when we transport things between countries. With Marina Tabassum, we talked about this at a dinner last night. How do you do bamboo in Saudi Arabia? And we did quite a lot of work on bamboo in Bangladesh with her. And then we brought it to London, and one of the problems that it had always was the joints in the bamboo were steel. So we tried 3D printing this, so on and so on, but the bamboo in London doesn't grow bigger than that, whereas you need the Bangladesh bamboo, large diameter. And why I show it to you is just putting it into an exhibition was that expensive. So one house that four people can live in Bangladesh versus one piece of exhibition in Royal Academy, which we brought from Bangladesh, but everything was made in the UK, cost 100 times. So if we hadn't done that, we could have saved 100 lives of the Rohingya. This is kind of a conflicting civilization. And associated with that is the paradoxical situation you're in, because there's a divisive idea about tall buildings. I talked to my friend, Dr. Fahad, about this sometimes, and I will continue that conversation. I wanted to introduce it to you because there are two reasons why we should continue to do tall building. We shouldn't stop, apart from the density discussion, but we have to do them better. So, for example, in Canary Wharf, everyone is an extrusion of a typical American idea of squares. And when we entered this competition, we challenged, which is as of the Miron architect, we challenged the idea of squares. We drew a circle, but also, more importantly, different typologies up the tower. So we go from a village type of double rooms to penthouses at the top. How do you differentiate? And our tools today can allow this. So what you're seeing here really is columns inside the building and core changing and moving in order to deliver a room that is different at every single level for this height. Technology can do that. The people that stop you doing that are your constructors and, generally speaking, your project managers, because they want what they did before, what was done by someone else. But if you reinvent the systems we know, you can do complexity like that in the built world. You can see that. In the central bank in Iraq, it's an opposite question. So here, when Zaha Hadid entered this competition, one of the things she said is, I want to repair the society. It's my people. Why wouldn't I do something that is contemporary, even though Baghdad looks like that, most of it? And how can I do something that is really different when it comes to tall building? So the purpose was no longer value or apartments. It's a headquarters for a bank. And one of the challenges she threw at us was really, how can I do a project that doesn't look at the east, west, north, or south? What is the scientific value you can add to this if you were to rethink it? And we rethought the way in which towers work. We start with the core at the base, and then we open the core, we turn the walls into a structural system. So at the base, where we need the most security from explosion or devices, it's strong. And as it opens up more and more, right at the top, which is where the bank manager will sit, is mostly open. So a wall turning into a column and twisting around can be designed in that way. Today, in January, inshallah, we're going to go and open it. It's taken 10 years to build it. Not because of any other reason apart from the supply chain was not very good, and we had to wait quite a lot to get this through the public. But if you're ever in Baghdad, they are now very proud of this building already. And I think it shows you that the divisive model of a tall building sometimes is about repairing a society. It's nothing to do with the building. And in the built world, you can go on, and you can add 20 floors onto existing buildings, 11 floors onto buildings, and so on. So to the left is the building we found, and then to the right is what we did to it. These things can happen, and you don't do it just for carbon footprint. We're now measuring with this how many lives we save, because then it gets to the knuckle. How many lives of 60 plus or young kids do we save by making less carbon today? And you can measure this. So it's vital that we continue along this line. And I show you now quickly some of the projects in London, because you'll be familiar with this. This is the old American embassy, which is just opened as the Chancery Rosewood, where we were speaking earlier about this building not being facadism, but in this one it was protected facade. The Americans had built with Sarinan and they wanted to save it. We won the competition to build it, but we didn't get the building for 3 years to go and explore. When we entered the building, we discovered that quite a lot of it was rotting, and we were able to prove all we could save was one wall on the front. So when I go back to that image at the beginning, sorry, I flipped through my slides a little, but we basically saved the skin of the building as much as we could and just held up that skin and then rebuilt 2 new basements and added a floor to it. So the next thing I want to talk about in this chapter, and I'm going to go faster, is how much we also lie to ourselves as engineers. On the left is 1983, the bicycle stadium in Calgary, very well known, built in concrete. The model is that. It's hardly anything under the ground. On the right is the beautiful stadium in London, which is like a kite trying to fly off in light timber. And the piles that were put underneath that are the model on the right with the elephant underneath. Nobody will ever be able to build on that site again. That's the reason why I show it to you, is you don't even know, as ordinary people walking the street, how much damage engineers have created below the ground. So I show you that in evidence against this won the Building of the Year. When we arrived on this site, we found Roman London underneath. This is Bloomberg's headquarters. And you can see the data there. We found nearly 14,000 artifacts of Roman London. Mayor Bloomberg was happy and Norman Foster was happy. But the thing that we did with it is really interesting, because we designed a facade that can live for 100 years. And we're not going to be able to open it because for the next 30, the air in London is bad. If we let it in, there'll be a lot of asthma. So we have designed it to a level where we know how we will deal with it. But the gray is what we had done as engineers over 100 years on that site. When we arrived, that's what we found on site, as well as the Roman London. And the red is what we did to enhance the ground, to allow us to build what you now see as a finished building. You can see the crazy engineering. And in the middle of the building, because we couldn't put any loads, we built a really beautiful ramp using geometry and art in the middle. So if anybody ever goes to visit this is the piece de resistance. And that was really about making people walk. Because if you do a beautiful thing like that, people will walk. And if you give them a view to St. Paul's, like the bottom right, they will also go there first thing in the morning. So there are all these social and behavioral changes that this building made happen. It also attracted the kind of people they wanted. I'm on this chapter 3, and this is the duality between the imposing and the understated. So I've shown you some really highly technological projects, but architecture is never neutral nor innocent. So I show you the last examples on this. In the Shanghai Expo, our model entry was, as the UK, we have no money, we have nothing, we don't produce anything anymore apart from knowledge. We claim to do a lot of things, but the one thing we have is grass, a lot of grass that we can take to China for the expo, uncoded British grass. That was the idea. So the conceptual model really was all we can afford as a pavilion is the orange blob, and the rest of it, we'll find a way of dealing with it. Very simple IKEA idea. Build a timber box like this on the left, because you don't want to make it complicated. Even my team could have gone there and assembled this. So build a timber box and then clad it in 100,000 hairs, which were the grass, and they could move. So ultimately, the idea was that this timber box could become this incredible space inside, and that could have seeds cast. So there are 100,000 different types of grass cast at the base of each one of these. And each one of these was then sent to a village in China to teach them about British grass, effectively. And we were lucky in some ways. Sometimes you have nice luck. When we finished, we stood back and we could see the Union Jack without any intention in our image. There was no plan to do the British flag. We just wanted to project David Beckham and the Queen with our photovoltaics. But for our luck, we managed to get all sorts of other things in there. So again, Zaha's Concorde moment, and I just talked about concrete in this because we did the most complicated concrete, would never go back. So Concorde for concrete was the Pheno Science Center. We did the thing that was the most impossible to do. Liquid with no columns, no walls, large spans, blah, 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 blah. And we managed to build it. It's celebrating its 20th anniversary next January. This was one of Zaha's original sketches. So you see many projects from the office, but this was her idea. And she took the idea to a level where in Azerbaijan, when they asked her to do the Sydney Opera House, we managed to build this thing, which many people hate. It's 50-50. But I can tell you that the success of the orchestra in there and the sound that you get inside the shape is one of the best performance halls that I had ever been in myself. And I'm not a great musician, but what's interesting about it is that the King of Morocco attended during the opening, and he thought I was an employee of Zaha and said to me, could you tell your boss, and I would like one in Rabat? Exactly the same. So there are these social and political, but also how we can succeed in changing cultures. And I have to say, when you go to Africa and you look up the vernacular, you wonder why you would do a Zaha did building there. But they wanted pride on the base of the river. And what's important is that pride is now appearing on their money. So you can see that there are different reasons for doing some of these things. It's got a beautiful landscape. Sometimes I feel that art, architecture, landscape, and engineering don't collaborate. So when you get an opportunity like this, where we were invited to a piece of art with Bjarke Ingels, we decided between us, how do we go back to combining all of these things? And we managed to do a twisted museum, which effectively is a very simple thing in structure, but you can see how beautiful it's turned out. And that work has moved technologically into crazy things like never being able to stand on an inverted stepwell, which we also managed to build. So I'm getting towards the end of this chapter before I finish. I do a lot of research. I go with my students to timber factories. I look at how important columns are, even though architects don't like them. The bigger and the more columns you have in a building, the more sustainable the building is. And we take this kind of work straight into real buildings. So for Google in London, where they wanted removable floors, we've used CLT, and you see that it's now nearly finished, 400 meters long. We've also put a real garden on top. So some of the research makes its way, some of this thinking, and even when it's finished, which it is now, you learn from your mistakes, because today we have a problem with fox infestation on our forest, and we're having to deal with that because we didn't realize the urban fox can climb up here. So last chapter, and I'll finish. So nothing is inevitable if we build through education, retrain the civic muscle. So point number one, the civic muscle of critical literacy, and nowhere better than a library to talk about that. And if we anchor ourselves in a proportional way to resist handing the megaphone to people you've all heard on CNN. When we hand over the megaphone to people who are not critical, don't have a civic muscle to change the world, I think there is a dilemma, and we are all ultimately bound by the earth. And we talk about innovation quite a lot. But believe me, up until now, over the last 2,000 odd years, it's been going down significantly. We haven't been innovating as humans. In fact, AI, which is the biggest elephant in the room that we now need to talk about, how do we bind AI into the earth? There are many ways of thinking about it. There are many ways cities can change, data-driven. But there's also an algorithm furnace in this idea. So it can also produce a lot of rubbish. To geotag humanity and then trace it is not wise because there's no spirit in that method of working. So I think this is one challenge, and connected to the climate challenge, the bigger one. So I'm also involved in more research on natural materials. So in Alola, I can't talk about the projects, but also connecting that to Las Vegas. So when I do this kind of work, I also use my teaching skills to go into the real material and look at the violence with which we are extracting material. And then, luckily enough, in Las Vegas, with Francis Kere, by showing some of these lectures, we both got invited to a competition for a new museum of all the places in the world in Las Vegas. And we're hoping to build it like that. I have been very interested, my last project, in waste for many, many years, right from the time I went to Sweden and saw how that society recycles. And that consequential impact of the research I did for 3 years at Harvard was the outcome was this waste plant that nobody wanted to live near. With Bjarke Ingels, the house prices have now gone up by 20% around it. It's not smelly, like people say. So making architecture and beauty out of infrastructure has been significant. I mentioned the word waste because with Prince Nahaf, we were very, very lucky to be the winners of this particular pavilion, the Masala in the last Biennale, which when we heard that this was going on, there was a debate in the office whether we should do it, what is it we can offer at this scale. We were very fortunate to work with East Architecture, and the client side were so clear about the brief that we were able to say, okay, let's test a new material. So it's gone. I'm not going to go into detail, but it's turned out to be, it got me out of bed. I really wanted to get involved, and we managed to prove that this could be done with Palm Front, particularly with East Architecture, Nicholas Fayed and his partners, who were interested in art, architecture, timber, and so on. So we saved a lot of carbon. And again, I say to you, don't think of it as waste. Think of it as how much life you saved. And they have managed, as the client, to take this wonderful object to Bukhara recently, where it's proven another thing which is about moving the object to different places. I'm finished, and I want to leave you with this final quote, which is an old quote from 1975, a historian. The 20th century will be remembered chiefly not as an age of political conflicts and technical inventions, which are some of the things I've told you already, but as an age in which human society dared to think of the health of the whole human race as a potential and practical objective. And what does that mean at this perilous time when we have the two challenges? One is AI, the other is climate. We can do the creating, we can do the synthesizing, we can do disciplines. No question, all of us can do that. The two areas that we're lacking in, I think, as designers, but also in the future, because AI won't deal with ethics and morals, and it's not going to deal with respect. Respect is the awareness and appreciation of, for different human beings. Ethics are responsibility to the world and the planet, but also to other citizens. And these two areas are, to me, the future of what I would like to leave you with. As a child, I was very interested in marbles, and I think they contaminated my brain, where I can't think of one color. I'm always thinking of many things at the same time. Thank you very much. Did I go over my time?
No, it's great. Great. We're enjoying the time. Thank you so much, Hanif, for such a fruitful, fully insightful lecture. We are deeply appreciating taking your time and sharing with us your experience and these great projects. I believe it's the approach in general, the interdisciplinary approach that we were talking about before, pushing the boundaries and being Hanif as a truly collaborative with many great designers. I know you are the one who, all the designers in the world, reaching out to win the competitions.
Yes.
Yeah. So please join me in giving Hanif a last round of applause. Thank you so much.
Thank you. Thank you for inviting me, by the way. Thank you so much.